Hello, ladies and gentlemen. Today we're going to be taking a look at coordinate geometry and how this can be applied to those parallelogram shapes we've been talking about. For this, you're going to need your notes as well as a calculator, and especially those three formulas that we were working with, okay? So this is the first thing you need to get in your notes. How can we show a quadrilateral is a parallelogram using what we did yesterday? So now we're going to be looking at how do we prove or show that something is, in fact, a parallelogram shape. So here's our choices, or here's our ideas. First, we could show that opposite sides are parallel because that's a property of parallelograms. And how would we show that those sides are parallel? Using one of those three formulas. In fact, we'd have to use the slope formula because opposite sides are parallel is something that we can show with a slope. We can show that things are parallel lines. Our second option is to show that both pairs of opposite sides are congruent, so that the top and the bottom and the left and the right side are equal to each other. Well, anytime you're going to use the word congruent or equal, we need a length, or we need to show that we have the same length. And for that, we're going to need the distance formula. And last but not least, another big property of parallelograms is to show that the diagonals bisect each other. That means the diagonals will cut each other in half, okay, corner to corner. If I have a little parallelogram, remember, corner to corner, they are cutting each other in half. Now, bisect means in half or at the middle. And another way to show that those diagonals are in fact bisecting or meeting there at the middle of each diagonal would be to use the midpoint formula to do that. So these three formulas are things that we can choose as tools to help us show that in fact we have a parallelogram. So we're going to do a few examples here. The first one, given these four coordinates, A, B, C, and D, show that both pairs of opposite sides are parallel to each other. So this is saying show or prove using the work or using math, okay? So show with all of your work and your steps that opposite sides are in fact parallel to each other. The fact that the word parallel is used right here tells me that we need to find the slopes of the sides. And sometimes a visual is kind of handy here. Let's pretend I wanted to sketch out a little rough visual of what this thing would look like. 0, 1 might be about right here. 4, 4 might be up here. 12, 4 over 12 up 4 might be over here. Okay, and 8, 1 might be right here. So this is kind of what we're looking at. A, B, C, D. Okay, this is what our little shape might look like. So using the points or the coordinates, we want to show using our slope formula that our lines are in fact parallel to each other. The first thing we would want to do is show that AB is parallel to CD. Notice in my picture, AB, CD, I'd want to show using math that those lines are in fact parallel to each other. So what would I have to do? I'd have to find the slope from A to B. Now remember, slope formula is y2 minus y1 over x2 minus x1. I'll need the points from A and B here. So I'm going to just write them underneath. 0, 1, 4, 4. I'm going to go ahead and find the slope in between those. Slope is y from the second point minus y from the first point, x from the second point minus x from the first point. And I'll go ahead and calculate that. 4 minus 1 is 3. 4 minus 0 is 4. So the slope from A to B is 3/4. Now I need to compare that to the slope CD. Okay, slope of CD. So the slope from A to B, the slope from C to D. I need to do the same thing because I'm trying to show that those lines are in fact parallel to each other using math and what's called coordinate geometry here, okay? So CD, let's go ahead and use the numbers in those points, and I'll do the setup again here. Y from the second point minus y from the first point, x from the second point minus x from the first point. I just wrote my points underneath there so I wouldn't have to look up and down from my list up there. Okay, and I remember who's first and who's second. And then I'm going to go ahead and figure this one out. 1 minus 4 is -3. 8 minus 12 is -4. Remember, two negatives will make a positive. Yes, we can certainly say that AB is parallel to CD. I know that, okay? I know that because I'm seeing that those two slopes are in fact equal to each other. Now that only shows that AB is parallel to CD. What about the top and the bottom of our parallelogram there? We have to do the same thing. So we have to do the slope from B to C and A to D. So I'm going to show BC is parallel to AD. Lots of work. Yes, I know. We need the BC points now. 4, 4. I'm going to do BC right here. Okay, 4, 4 is B, and C is 12, 4. And we'll go ahead and set up that formula in the same way. So y from the second point minus y from, oh, sorry, my bad. Y from the second point minus y from the first point. X from the second point minus x from the first point. 4 minus 4 is 0 over 8. It looks like 0 divided by 8 is still 0. So the slope there is 0. Okay, the slope is 0. And then we'll go ahead and do the same thing for A to D. AD, I'm going to write my points right there so I remember who's first and who's second. And we're going to set up the formula. X or y from the second point minus y from the first point, x from the second point minus x from the first point, 0 divided by 8 again, still 0. Whoops. So I have now shown, because those two slopes are the same, that BC is parallel to AD. This is what coordinate geometry looks like, okay? We're showing, in fact, that something is true using coordinates on a graph. It's more than just making a picture and saying, look, it looks like it. It's showing using your math and being able to show that to somebody else. That's the important part, okay? It's going to be a little bit of work, but don't worry, you won't have so many to do at one time. Okay, let's do a different method this time. We're going to use these 4 coordinates, A, B, C, D, to show that both pairs of opposite sides are congruent. Okay, so remember our last little picture here? Let's say A, B, C, D, something like this. Okay, that shows me how all these sides are going to work out. Same deal here. We want to show that opposite sides are congruent. Now, when you see the word congruent here, that means equal in length. So to do this, we're going to have to use the distance formula. So we're going to do distance formula many times. Actually, 4 times because we have 4 sides. So here we go with the first side. On my parallelogram, one side would be A to B. So the distance formula is the one that has the funny big long square root here. Point A, I'm just going to write the point right here next to him so I remember who's first and who's second. Okay, and then we're going to plug them in. Formula looks like this. It is x from the second point. Actually, I think I'll do the y's first. Y from the second point minus y from the first point. X from the second point minus x from the first point. It doesn't matter if you do x's or y's first. We're just going to add them in the end. Okay, now we need to calculate what's happening inside of here. 7 minus 3 is 4. I have 4 squared. This, 2 negatives make a positive there, negative 3 squared. So what I have is the square root of 16 plus 9. That's the square root of 25, ladies and gentlemen. And that is 5. So the length from A to B is 5. Now we need to check CD. Because according to my little picture up here, if AB matches CD, then we're talking we have a parallelogram here. So let's do the same thing with my points from C to D here. 3, 6. 6, 2. Here we go. You can do x's or y's first. It doesn't matter. 2 minus 6. 6 minus 3. Plug in those numbers, okay, from your points there. You're going to calculate negative 4 squared. 3 squared. Negative 4 squared is 16. 3 squared is 9. So it looks like, again, I have the square root of 25, which is 5. So far, so good. Those two sides are, in fact, congruent to each other or equal. But we still have 2 more sides, ladies and gentlemen, because it says show that both pairs of opposite sides are congruent. Not just that the left and the right sides are congruent, but both pairs. So we need to go ahead and do the same thing for BC and then AD. So if you feel like you can do that, you can pause the video now and see if you get your answers to work out to be the same. But I'll go ahead and set up my distance formula again. Okay, x from the second point minus x from the first point. Can't read my writing here. Oop, that's a 7. Okay, y from the second point minus y from the first point. Here we go. Plugged in numbers. 3 minus a negative 5 is like adding here. This is 8 squared. Plus, oop, that would be negative 1 squared. 8 squared is 64. 1 squared is 1. That is 64 plus 1. That is the square root of 65. Okay, square root of 65. Can 65 be simplified? Can we divide a 9 out of them, a 16 out of them, anything like that? The answer would be no. So we'll leave them alone as the square root of 65. Okay, then we'll look at from A to D now. Negative 2, 3, 6, 2. Let's do the same thing and make sure, hopefully, he's the same thing as the square root of 65. X from the second point minus x from the first point squared. Plus y from the second point minus y from the first point squared. Okay, so inside there, 6 minus a negative 2 is like adding. I have another 8 squared. Plus, that is negative 1 again, squared. 8 squared is 64. Negative 1 squared is 1. This is looking good. We have the square root of 65. So we have now shown that both pairs of opposite sides are, in fact, congruent to each other. Okay, nice job. Lots of writing, but nice job. Let's do one more and then we're done. Given these 4 coordinates, again, so all we have are numbers here, we need to show that the diagonals bisect each other. So I'm going to sketch myself a little picture. It doesn't have to be perfect up here. Remember, let's pretend this is A, the B, the C, and the D. And we need to show that diagonals will bisect each other. So this time, rather than talking about sides, we're talking about diagonals. And then the word bisect means in the middle or cut in half. So for this, I'm going to use the midpoint formula on the diagonals. So I need to identify who my diagonals are. One diagonal would be from B to D. So I'm just going to write that down here. BD is a diagonal that I want to look at. And then I also have a diagonal who would be from A to C. And what am I going to do to A, C, and B, D there? Those points, I'm going to find the midpoint. So diagonal BD, I'll just write the points next to them again, the coordinates here. And we're going to find the midpoint now. So I'm going to use the midpoint formula to prove that it's cut in half, or in fact, I found the middle. So the midpoint formula has a comma in between there, okay, just like last time. And this time we add the x's and y's together. So negative 3 plus 3 are the two x values divided by 2. And then the 4 plus the negative 5, the y values, get divided by 2. And so the first part here, negative 3 plus 3 is 0, divided by 2 is still 0. Negative 1 divided by 2 is negative 1/2. So the midpoint from B to D is 0, negative 1/2. Let's do the same thing for AC. Negative 3, 0, 3, negative 1, and we'll do the midpoint formula again for those. Midpoint formula, add the x's, divide them by 2, add the y's, divide them by 2. And we'll simplify. 0 divided by 2 is still 0. Okay, that's 0 divided by 2. This is negative 1 divided by 2. So what we have just shown is the midpoint from A to C. Now look at that. They match. Okay, they're in the same spot. Okay, that means they meet at their midpoint. We have shown that the diagonals will, in fact, bisect each other. They are the same, so the diagonals are bisected. All right, so that concludes our lesson today, ladies and gentlemen. There's a lot of formula use today, but identifying which formula you use when is our key focus, okay? And trying to show using our math what's supposed to happen. Thank you for taking good notes.